Hello, I'm Morad Zerouni. I'm an engineer and I work as a member of Huesker Synthetics engineering department in the application area of roads and pavements. In this videocast, I would like to introduce you to the functions of geosynthetic asphalt reinforcement. The volume of traffic on our roads and airports is constantly increasing. The growing need for mobility and services, coupled with the expanding trade in goods, is stretching our transport infrastructure to its limits and has clearly taken its toll on existing facilities. The traffic loads on roads and pavements are compounded by daily and annual temperature variations, with the resulting failures visible as deformations, cracks, and potholes. Despite the extremely high and almost permanent loads to which asphalt and concrete pavements are exposed, they are required to fulfill their function of connecting people and facilitating the supply of goods and services. Our roads and airports are subject to a continuous process of optimization. Resource shortages and the growing cost awareness among all project team members have fueled the demand for innovative materials and alternative sustainable construction methods. Advances in asphalt mixes, concrete formulations, and installation methods have been accompanied by new developments in repair and maintenance practice that are being increasingly applied. One of the most common failure mechanisms, particularly in connection with asphalt pavement rehabilitation works, is reflective cracking. Typical causes of this type of cracking include cracks in the original pavement, joints, seams, and excavations for utility lines, sewers, or road widening schemes. Exposure to traffic loads and daily or seasonal temperature variations, particularly in the form of freeze-thaw cycles, induces stress concentrations at the crack tip that encourage free upward crack propagation. Should the reflective cracks reach the surface, then the situation rapidly deteriorates due to the additional ingress of water and oxygen. One effective and time-tested solution of significantly retarding and preventing reflective cracking is the use of flexible asphalt reinforcement. An asphalt interlayer can fulfill three main functions, and depending on the application, one or several of these may be met by a single product. 1. Sealing function, to prevent the ingress of water and oxygen into the asphalt pavement. 2. Reinforcing function, to accommodate tensile stresses where incorporated in a structurally continuous assembly between two asphalt layers. 3. Stress relieving function, where incorporated in a flexibly bonded assembly, for example, for concrete pavements with asphalt overlays. A wide range of applications exists, and each of these requires the selection of appropriate raw materials. Asphalt reinforcement products made from polyester, glass fibre, or polyvinyl alcohol, PVA, are available and are selected according to the type and nature of the base and the planned rehabilitation solution. Particularly for applications in alkaline environments, specification of the correct raw material is essential. The rehabilitation of concrete or partially cementitious composite pavements with a high pH value necessitates the use of alkali-resistant raw materials such as PVA. Apart from the choice of raw material, various other product-specific properties are crucial to optimizing performance. A material's resistance to installation damage, for example, provides a clear indication as to how well it will actually perform in the installed condition. Products may, for instance, be susceptible to installation damage when laid on milled surfaces, when driven over by asphalt trucks, or during compaction of the overlying asphalt layers. The mandatory test procedure is described in detail in DIN N ISO 1072-2. A further key feature is the provision of a polymer-modified bitumen coating with a minimum bitumen content of 60%. Through adhesion and friction, this coating creates a strong structural bond with the surrounding asphalt, while simultaneously providing the reinforcement grid with high protection against installation damage. Adequately sized grid apertures additionally promote the interlock between the asphalt layers, thereby enhancing the structural integrity of the layer assembly. Working Paper 770 on the use of non-wovens, grids and composites in asphalt road construction, issued by the German Road and Transportation Research Association, FGSV, summarises the key properties and associated test procedures for the use of asphalt reinforcement products in pavements. Selection of the appropriate system solution and compliance with the installation regulations and guidelines for asphalt road construction are crucial in ensuring the proper performance of asphalt reinforcement. The up to 4-fold retardation of reflective cracking extends the service life of the rehabilitated pavements and thereby lengthens the associated repair and maintenance intervals. Further benefits during the service life of pavements include a reduction both in the volume of roadworks and in the resulting traffic congestion and CO2 emissions. The use of HaTelit, asphalt reinforcement, allows rehabilitation costs to be cut by some 40% in comparison to standard rehabilitation methods. General experience has shown asphalt reinforcement to offer a cost-effective rehabilitation solution for roads and airport pavements. I hope that this presentation has captured your interest. Should you wish to know more about the technical details of Huesker's solutions, then please take a look at our website or contact us directly. Our team will gladly provide you with support, also on interdisciplinary issues.